Hello dear students, welcome back to physics online class. So today we will be discussing about that symmetry rule. So in order to solve that complex circuit, so for example, so we know that how to solve that if the resistance are connected in series combination and as well as in parallel combination. Sometimes, so if that circuit is too much complex, so I need some tricks to resolve that circuit. So I said that, so in order to find out that equivalent resistance, so my duty is to means I have to simplify that all the resistance in a such a way that all the resistance should be in series or all the resistance are should be in parallel between the points. So then easily I can find out that effective resistance. So in case of that complex circuit, it is too much difficult to simplify that. So for that purpose we will use a symmetry rule to simplify the circuit here. So in today's session, so we will be discussing about that symmetry rule here. So it is very much important for that competitive examination aspect. So let us start our session with symmetry rule here. So in case of that symmetry rule, for example, so just I will take one small example, then we'll look after that complex circuit here. For example, in that given circuit, so let me write that one circuit here. So for example, its value is resistance of this resistor is 2R, this is also 2R, this one is R and this one is R, and here one more resistance I will place and its value is R here. So find that equivalent resistance between that point A and B here. So in order to find that equivalent resistance between these 2 points, so first I will apply that symmetry rule. So symmetry means, so similar side you can consider. So in case of symmetry, so first I will consider that mirror symmetry here. So mirror symmetry means, so I will take that perpendicular line here. So for example, if I drawn that perpendicular line means, so look at here. So that exact image will get formed here. Here 2R is there, here also 2R, here R is there and here also R is there. So exact duplicate image is going to form here. So this kind of circuit we will take it as mirror symmetry here. So this circuit example for that mirror symmetry here. So did you get my point? So for example, even butterfly is there. So you can take that exactly at that body. So left side and right side having that similar things here. So here that left side. So in left side here also 2R, here also 2R. In left side here also R and here also R term is there. So this is an example for mirror symmetry. So in case of that mirror symmetry, for example, if that here I amount of current will get flow. For example, here that I amount of current is flowing means here I1 amount of current is flowing. Here I2 amount of current will get flow here. So in case of that mirror symmetry, so here current I1 means here also current should be I1 only. Here current I2 means, so here also I2 only. So what it mean here? The same current. So mirror image will get formed here. So if I take that one mirror means, so exact duplicate image will get formed here, right? So here 2R, here 2R, here I1, here I1, here R, here R, here I2 and here also I2 term is there. So in this situation, so in this part, so in this terminal, there is no flow of current here. So if there is no flow of current means this resistance doesn't take any kind of effect in case of that effect resistance. So look at here. So in this branch, there is no amount of current. So if there is no amount of current means, so this circuit means this resistance doesn't make any kind of affection. So it is one, you can take this is one dummy circuit here. So I can neglect this one. Why? Because if there is no current means there is no concept of resistance. So current is not flowing means, so its effect is nullify here. So there is no effect here. So now easily I can solve this circuit. So look at here. So 2R and 2R, what is the nature of combination? So these two are in series combination. So in series combination, R of S is equal to R1 plus of R2. Please look at the previous videos here. So these two resistors are in series combination. So in case of that series combination, R of S is equal to R1 plus of R2, here 2R and here 2R. So total resistance will be 4R. Instead of 2 resistance, I get that single resistance. So its value is 4R here. Here also R and R are in series combination, R of S1, this one is R of S2. So R plus of R here. So this is equivalent to, so 2R here. So instead of 2 resistors, I will take that single one. So this is 2R. So point A and this is point B here. So what's the nature of combination between 4R and 2R? So that is parallel combination. So finally, in case of parallel combination, R1 into R2 divided by R1 plus of R2 here. So R1 means 4R, R2 means 2R here, 4R plus of 2R here, 8R square by 6R here. One R term will getting cancelled out here. So 2 3s are 4. So effective resistance between the terminal will be 4 by 3R. So look at here. Here initially one resistance is there, R. So that resistance is dummy, means it doesn't make any kind of affection to the total network here. So this circuit I need to vanish here. So for that purpose I use that symmetry rule here. So in case of that mirror symmetry, if current I1 is there means here also should be I1. If here I2 means here also current should be I2 only. So there is no amount of current will flow in this middle portion. So if there is no current means there is no resistance. So it doesn't alter, means it doesn't affect to the main circuit. So I vanish here. So I just rub out here and then the circuit will become simple here. Now I can able to solve this effect resistance between the terminal A and B. Now we'll take another complex circuit here. So this is a simpler circuit. So in this simple circuit, easily we got that effect resistance between the point. So if that circuit is somehow complex here, so in case of that complex circuit, so how to solve that effective resistance between the terminals? So let me draw on that circuit here. Okay. Okay. So each value I will name it as R here. So R, R and R. So here point A I will take and here I will take that point B. So now my duty is to find out that effective resistance between point A and point B here. So look at here. Is there any possibility of mirror symmetry? So first I will draw one vertical line here. So look at here. If I draw one vertical line, is that mirror image will get formed here? So look at here. If there is a mirror means here also R, here R, here R, here R, and here also R term is there, here also R term is there, here also R term is there. Yes. So this is example for mirror symmetry. Now look at here. If there is a mirror symmetry means, so in case of that mirror symmetry, LHS is equal to RHS. So keep it in mind. So for example, here I amount of current will get flow. Here current I1 will flow. For example, here current I2 will flow. Here also same current I1. So if it is mirror, here current I1 means here also current should be I1 only, and here also I2 means here also current I2 will get flow here. So look at here. Here current I2 is there. Here also current I2 is there. So here current will not get split here. So here current will not get split means, so just I can retake this one. So this point is not attached to the edge. So for confusing us, they given like so. Actually, if I take it as a mirror symmetry, so current is not flowing means, so this is not connect here. So if it is not, so here the connection is there. So again here that current will get divide here. So now that circuit is somehow simplify here. Now look at here. What is the nature of combination between R and R? So these two are in series combination. Within a fraction of second we can able to solve this one. R and R are in series combination. If these two resistors are in series combination, R of S is equal to R1 plus R2. So that is equal to 2R. Shall I write it as 2R here? Instead of two resistors, so just I will take it as single resistor here. So that is 2R. Now look at here. What is the nature of combination? End to end. Instead of two resistors, again shall I take it as a single one? So that is also 2R. So these two are in series combination. So look at here. So these two are in series combination. So that value is also, sorry. So that value is also 2r only. Now look at here. So I will rewrite it here. So as it is r, I am writing. What is the nature of combination between 2r and 2r? So that is parallel. So in case of parallel combination, r1 into r2 divided by r1 plus of r2. I will go fastly here. So 2r into 2r divided by 2r plus of 2r. 4r square. Sorry. 4r square by 4r here. So what's the value here? So this is r here. So instead of two resistance, I will take that single resistance now. So this is r. Again that. So look at here. R and R. So it is in series combination. Shall I take it as a 3R here? Instead of 3 resistors, just I will take it as 3R here. So this is 3R. These two are in series combination. Shall I take it as a 2R here? So R and R. So R plus of R, 2R here. 3R and 2R. What's the nature of combination? So that is parallel here. So R of P is equal to 3R into 2R divided by 3R plus of 2R. So my duty is over here. So look at here. 6R square divided by 5R. One R term will getting cancelled out. 6 by 5R. So effective resistance between the point AB is 6 by 5R here. So look at here. In order to solve that complex circuit, so I are using symmetry rule. So I use that. So mirror symmetry. So if left hand side term is equal to right hand side, so then I can take that same amount of current will get flow here. So I got some simple circuit here. So some terminals will get cancelled out, or I will get that simple circuit here. So you can simplify the things easily, you will get that. So effect resistance between the 2 point here. So now we'll look at that another example for that symmetry rule here. For example, again I will take one circuit here. So allow me to draw the circuit here. Similar example I will take. Okay, here I will take it as terminal A and here I will mention as terminal B here. Here R I will take, here 2R I will take, here R I will take, here 2R I will take. For example, here this is one is R. So now look at here. If I take that mirror symmetry, is it work here? So look at here. If I take that mirror symmetry, so is that any reflection is there? So no. Here R is there, here 2R term is there, here also R term is there, here 2R term is there. So it is not that mirror symmetry here. So instead of taking that, so just I will take that along horizontal direction. So that is, if I fold this page, for example, if I fold this page, so look at here, here R term is there, here also R term is there, here 2R term is there, here also 2R term is there. So look at here, now I will take in this way. So look at here. So now I divide this circuit in this way. So this type of circuit I will take it as folding symmetry. What its name? Folding symmetry. So in case of that folding symmetry, so look at here. So if I fold this page, so look at here, R will get again R here. Here 2R term is there, here also 2R term is there. So just I will give that potential here. So for example, if there is potential X means here also X, and here potential Y, in this point potential Y, here that potential is Z here. So look at here. So between that X and Y, so resistance R is there. Here also between X and Y, resistance R is there. So look at here, potential between XY here and potential between XY. So here potential will be same here. So if that potential is same, means in parallel combination which quantity will be remains same. So in parallel combination potential difference is remains same. So look at here. So this R and R, so it is in parallel combination. So did you get my point? Between X and Y resistance R is there. Here between X and Y potential resistance R is there. So potential is same, means so R and R. So these two are in parallel combination. So look at here. Here at point Y and Y, so resistance R is there. So listen carefully. Here also potential Y. Here also potential Y is there. If same potential means, so potential value is 0. So when there exists a potential difference, then only current will get flow here. So remember one thing, when that current will flow here, so in case of the battery, there should exist a potential difference here. So then only current will get flow. For example, if you take two tanks here, in one tank if you fill with the water completely, another tank is empty. If you give that pipe connection, so that water will get flow from that high, means full contained water to a empty tank here. So if both tanks are same, so if both tanks are filled with the same quantity, means same height of water, means water will not get flow here. Why? Because it attains a common potential. So water will not get flow from that one tank to another tank. In the similar aspect, so here also potential Y, here also potential Y is there between the resistance. So between the resistance, potential is same. So there is no potential. So if there is no potential, means so current is not there. If current is not there, means so again this circuit is dummy only. So it doesn't make any kind of affection. Again this circuit I will rub out here. So look at here, between YZ, so there exists a potential. Here potential is Y, here potential is Z. There exists a potential difference. Here also resistance 2R, here also resistance 2R. So these two resistors are in parallel combination. So remember here, in case of folding symmetry, so I can take that between X and Y, so resistance R is there, here also resistance R is there. So these two resistors are in parallel combination and these two resistors are in parallel combination. So remember here, so here this circuit doesn't make any kind of affection. So in case of folding symmetry, upside down I can take. So in case of that upside down, so look at here, so potential is same here. So between X and Y, here also between X and Y, resistance R is there. So potential is same, means so it is in parallel combination. So R and R are in parallel combination. So instead of taking two resistors, so R of P is equal to what? So R of P is equal to, so look at here, R of P is equal to R1 into R2 divided by R1 plus of R2 here. R1 is R, R2 is also R plus R here. So R square by 2R here. So R of P is equal to what? R by 2 here. Instead of two resistance, I will take that single resistance. So its value is what? R by 2 here. So look at here, 2R and 2R. So just will take mathematics here, 2R into 2R divided by 2R plus of 2R. 4R square by 4R. So look at here, so term R will get left here. So instead of two resistance, I will take that single resistance. So that is R. Okay. Between the terminal A and B, I got that two resistance. What are those? R by 2 and R. What is the nature of combination between R by 2 and R? So these two are in series, R by 2 plus of R here. So 2R plus of R. So 3R by 2. What is the effect resistance between these 2 points? Effect resistance between that these 2 points is 3R by 2. So hope you understand here. So if you take that folding symmetry, so in case of that folding symmetry, you can take that same potential. So potential difference I can take. So potential difference between R and R. So I can take that these two resistors are in parallel combination here. So let me solve one complex circuit. Okay. So we'll look at that. Another one more example related to folding symmetry. So for example, I will draw one circuit here. So I want to find out that effective resistance between 2 points here. So this is one circuit. So in this circuit, I want to find out that effective resistance. Okay. So this is somehow complex circuit. So in this complex circuit, so I want to find out that effective resistance. So look at here. So it makes of course it will make confuse us. So here this one is point A and this one is point B. So let all the resistors having that resistance are here. So My interest is to find out that what is the effect resistance between the point A and B here. So now this circuit I will simplify by that folding symmetry here. So for example, if I fold in this way, so look at here, so upside down, same R is there, R here also is there, R, and this R will get overlap here, this R will get overlap here, this R and this R will get overlap here. So this is about folding symmetry. So in case of folding symmetry, I can solve by taking the potential value. Here potential is X here. So for example, here midpoint also I will take that potential. So at that midpoint potential be Y, and here that potential will be Z. So at the center I will take it as O here. So for time being I will take that point A, I will take it here, and point B I will take here. So look at here, between XY resistance R is there, between XY resistance R is there, potential is same. So R and R, so these two are in series combination. YZ, here also YZ, R and R, these two resistance are in parallel combination. So these two resistance are in parallel combination and these two resistance are in parallel combination. So look at here, between O and X resistance R is there, between O and X resistance R is there. So these two resistors are in what? So that is parallel combination. Similarly, O and Z, here also O and Z resistance R is there. So these two resistors also in parallel combination. Between A and X resistance R is there, between that A and X resistance R is there. So these two are also in parallel combination. So now I can solve that. If these two resistance are in parallel combination, what is that effect resistance? So R of P is equal to what? R1 into R2 divided by R1 plus of R2. R into R divided by R plus of R. So this is R square by 2R. So that is R by 2 here. Instead of two resistors, I will take it as single resistance. So I will rub out here. So instead of two, I will take it as single resistance, R by 2 and R by 2. So these two are also in parallel combination. Instead of single, I will take it as, instead of 2, I will take it as single resistance, R and R. So A and X is there. Here also A and X is there. So of course, these two resistors are also in parallel combination. So I will take, this is also R by 2. So this circuit is also R by 2. Similarly, I will take R by 2 and I will take R by 2 and I will take R by 2. Now the circuit is simple now. So now let me find out that what is that equivalent resistance. What is the nature of combination between R by 2 and R by 2? So these two are in series combination. So in series combination, R of S is equal to what? R1 plus of R2. R by 2 plus of R by 2. So if 2 is LCM, 2R will get cancelled out. So that R of S is equal to what? R here. Instead of two resistance, I will take it as single resistance here. So this is R here. So again, these two are also in series combination. So way is different, but end-to-end connection, R by 2 and R by 2. Both are in series combination means, so this equivalent resistance is R. So your duty is to first solve that some simple circuit. In last video, we discussed some simple circuit here. So if you know how to solve the simple circuit, you can easily understand about that complex circuit. Now look at here, R and R, again these two resistance are in parallel combination, R into R divided by R plus of R. So that is R square by 2R. So finally I will get it as R by 2 also. So again, don't make confused here. So that is R into R. So here R is there. So here term R is there means R into R divided by R plus of R, R square divided by 2R. So that is R by 2. So that only I written here. So this is R by 2. Finally, R by 2, R by 2 and R by 2. What is the nature of combination? End to end only. So end to end means what? So series connection. So I got that effective resistance R by 2 plus R by 2 plus R by 2. So that is 3R by 2. What is the effect resistance here? 3R by 2. So such a complex circuit easily I can simplify here. So I will get that effect resistance between the 2 points in a easier manner. So this is a way, means this is how we can solve that complex circuit by using symmetry rule. So we can use that folding symmetry, or we can use that another one is mirror symmetry. We will look at another complex circuit. So in this circuit, I want to find out that effective resistance between 2 points here. So I will make complexity as much as possible here. Okay, so this is one circuit. So in that given circuit, I want to find out that effective resistance. By looking only, it seems like dangerous. So I want to find out that effective resistance between that point here. So I will choose the point. So in that given point, I want to find out that effective resistance. So let it be point A and B here. So between these 2 points, I want to find out that effect resistance. So let that all the resistance having its value is R here. So now I want to find out that effect resistance between A and B here. So I want to simplify this circuit by folding symmetry. So for just assumption, take that if you turn like this, so this is act like a folding symmetry. So if you turn this one, it becomes as a horizontal. It seems like a folding symmetry. Let that potential at this point is X, potential at this point is Y, and remaining thing will be same. So look at here. Here also potential X, here also potential is X. So potential is X and X. So there is no potential difference. So there is no potential difference means there is no current. So this circuit is dummy here. Here also Y, here also Y term is there. So this is also dummy circuit. So I want to vanish it. Now look at here. In this circuit, I want to find out that effective resistance here. So this one is point Y and this one is point Y here. So look at here. Between that X and B, what's the resistance here? Resistance R is there. Between X and B, what is the resistance here? Resistance R is there. So potential X and B, and here also X and B. So here also resistance R is there, here also resistance R is there. These two resistors are in a parallel combination. So simply I can write it as a R by 2. R into R divided by R plus of R. R square by 2R. So that is R by 2. So instead of 2 resistance, I will take it as single resistance now. Similarly, between Y and A, so what is the resistance? R is there. Between Y and A, resistance R is there. Instead of 2 resistance, so just I will take it as single resistance. So that is R by 2. So look at here. Between X and Y, what is the resistance value? R is there. Between X and Y, what is the resistance value? R is there. So here that potential is same. So I rubbed this. So this one is imaginary line. X and Y resistance R is there. Here also X and Y resistance R is there. So these two are in parallel combination. Instead of 2, I will take it as single resistance. So look at here. Now I want to simplify this circuit. I want to find out that potential between AB here. Look at here. R by 2. Here R by 2 and here R by 2. So these three resistance are in series combination. So look at here, R by 2 plus R by 2 plus R by 2. So shall I write it as 3R by 2 here? So instead of taking R by 2, R by 2, R by 2, I will take it as equivalent resistance. So what's that value? So that is 3R by 2. This is 3R by 2. So finally I got that. R and 3 are in parallel combination. I will get that effect resistance here. R of P is equal to R into 3R by 2 whole divided by R plus of 3R by 2. So 3R square by 2 whole by. So 2R plus of 3R, 5R by 2 here. So if it is 5R by 2 means 2 term will getting cancel out. So R of P is equal to what? 3 by 5R. What is that? Equivalent resistance here. Equivalent resistance between the point AB is 3 by 5R. So hope you are understanding these things.